You are in which class now? 11th or 12th?
11th.
Okay,
11th.
you have just gone to 11th. How was your 10th boards?
Good, sir.
Good. Percentage?
Overall or math?
Both.
Math I got 99. Overall was 96 percentage.
Okay, 99.
Math.
In 99 in maths, very good marks. And then why you are looking for one-to-one classes?
Uh, in 11th in my school they teach. They give more importance to JE. So I won't have much time for CBSE and JE
Okay,
preparation from basics.
got it. And they'll be going very fast.
Yes, sir.
That is usually the case. That's why. Okay, there are few students who face the same difficulty. Is my screen visible to you?
Yes, sir.
Okay. So you are in class 11, and if we discuss about maths, have you gone through what topics we have to cover in class 11 maths?
Yeah, I have gone through the first chapter.
Okay, you have covered the first chapter also.
No, in my school they just gave a briefing regarding the first chapter, sets and relations.
Okay, got it. We have to cover, I'm just giving you a rough idea that what we'll be covering over the whole year. The first one is set, relation, and functions. The second one is we have to cover is some algebra topics. In algebra, we'll be covering like, I think someone is there. One second. Hello. Hello.
Yeah, good afternoon, Diwakar.
Good afternoon. Good afternoon. She has joined. We have started the
Yeah,
classes.
okay.
Okay. Is my screen
Okay,
visible
let
to
me
you?
join. That's okay.
Okay.
Yeah, just you continue. Just
Okay.
I will watch.
Okay.
Okay.
Is my screen visible to both of you?
Yes, sir.
Okay. So first
Yes,
topic we have to cover is set, relation, and functions, and then we have to cover some topics related to algebra, like the PNC, permutation and combination, sequences and series. We have to cover binomials, binomial theorems. Are you aware of binomial term? What is the meaning of binomial?
Monomial, binomial, like two terms.
Exactly. And you must be having some idea about the sequences and series also. In class 10 there was arithmetic progression, right?
Yes.
So we'll be further building upon those parts. We'll be discussing AP, GP and HP. So binomial theorem will be covering complex numbers. Any idea about complex number?
They are unreal numbers.
And no, it's not like that. We divide all the numbers into two parts, real number and imaginary number. The standard form of complex number is a plus ib. There will be some real part and there will be some imaginary part, right? Similarly, we'll be having some more topics like principle of mathematical inductions and all. Then we'll be discussing the most important topic of class 11, that is trigonometry. Very important. It is not only important for class 11, it is very important for studying the calculus part, which we will be discussing in class 12. So this topic should be very strong. And the next is coordinate geometry. Coordinate geometry, some idea we have already got in class 10th, right? Like the distance formula, section formula, area of triangle and all. You must be having these idea, right?
Yes.
What is the formula? What is distance formula if you have 2 points P and Q?
Root of x2 minus x1 the whole square plus
Correct.
y2 minus y1 the whole square.
Okay, and what about section formula? What it says?
The formula
Yes, formula. If
m1 x2 plus m2 x1 divided by m1 plus m2 comma m1 y2 plus m2 y1 divided by m1 plus m2.
got it. We'll be discussing here external division also. I think you must have not gone through the external division part that we generally don't discuss in class 10. We'll be discussing a lot in coordinate geometry. We'll be discussing about the straight lines, circles, parabola, ellipse, hyperbola very properly, and then we'll be discussing statistics, stats, and probability. These are the topics that we have to cover in class 11 maths. Okay, if you have a notebook now, you can note this. Have you taken the notebook?
Okay. Yes sir, I'm taking it.
Okay, note. Out of all these parts, trigo is the most important.
Okay sir.
Some introduction we have already got in class 10th. Trigonometric ratios, some interconversions and all.
I am noted sir.
Very good. Which topic we can start? Tell. You can pick any.
Sets and relations.
Sets and relations. Okay. Firstly, let's discuss about the sets. As you mentioned that you have already covered sets in your class, what do you understand by set? Any idea?
No sir, they haven't gone much deep.
Okay. Whenever we say that it is a set, it is not a set, we just define like it is collection of well defined objects. Well defined objects. That's enough for sets. Whenever I write like, suppose I write A as 1, 2, 3, 4, 5 dot dot dot, and I ask you whether this particular thing A is representing a set or not. We will say it is representing a set because they are well defined, right? Why? Because they are natural numbers. Do you understand what are natural numbers?
Yes sir.
What are natural numbers?
Numbers from 1 to infinity.
1.5?
No sir.
1.5 is not a natural number. Sure. But you are saying that from 1 to infinity you will say it as natural number. So 1.5 also comes between 1 to infinity. Then
1.5 can also be represented as a fraction.
okay. Natural numbers are just called as the counting numbers, right? All counting numbers are called as natural numbers. I will just give you some idea. I think you must be having, but let's discuss a bit about the numbers. We divide numbers into two parts, as I mentioned earlier also. Here, real and imaginary. What are real numbers? Any idea? In class 10th you have covered.
All the rational numbers, irrational numbers.
Correct, correct. You can say that combining all rational and irrational. All rational and irrational. Or one more thing we can say is all numbers which can be represented on number line, or say the real line, right?
Yes.
I can say 1, 1.5, 1.666, whatever, root 2, root 3, all can be represented on number line, and we'll say it as real number. What are imaginary numbers?
The numbers which cannot be represented in a number line.
Okay, and one important thing that you should be knowing here is imaginary numbers are like whenever you have inside the root a negative. That means if you have root minus 2, it's called a imaginary number. We'll be discussing in detail while we discuss about the complex number. There's a separate topic, right? As for now, just keep in mind that imaginary number have inside the root a negative number, right? Like root minus 2, root minus 5, root minus 7, all these are imaginary numbers. They cannot be presented on number line. What are rational numbers?
Numbers which are represented in the P by Q form and Q is not equal to 0. P is an integer and Q is not equal to 0.
P is an integer. If I write 2 by root 5, is it a rational number?
No sir, it's irrational.
But as you said, P by Q form, Q is not equal to 0 and P is integer. It is satisfying all the definitions, right?
Yeah, but in the rational numbers, I forgot to mention one thing. Both P and Q
Exactly,
are
exactly. So here P by Q form, Q is not equal to 0, and HCF, or say the GCD, HCF of PQ is 1. That means you have cancelled whatever there was possible, right? HCF of PQ is 1, and then P and Q are integers. Okay, we'll call it as rational number. This is a complete definition. If I am saying 2 by root 5, it is violating what? It is violating P and Q are integers. If I write 2 root 5 by root 5, is this a rational number?
yes sir, because root 5 and root 5 can be cancelled.
Exactly, and we'll get 2 by 1. It is in the form of P by Q. Q is not equal to 0. HCF of PQ is 1, and P and Q are integers. That's it. So we are very clear with the rational numbers. And one more thing I'd like to connect here is when we say that set is a collection, it is a collection of well-defined object. If I am saying a real number is well-defined. We know what the real number is. Rational number is well-defined. We know what the rational numbers are, right? Irrational number is also well-defined. That means all the numbers, natural number, whole number, prime number, composite number, all the numbers are very well defined. So we'll be considering as an example of set. Natural number will be a set, whole number will be a set, integers will be a set, real number will be a set, right? All these are examples that are very well defined. Okay, further if I discuss, what are irrational numbers?
Numbers which cannot be represented in the P by Q form.
P by Q form. Okay. Okay, you can say it. All those numbers which are not rational will be called as irrational. That kind of thing you want to say, right?
Yes.
Okay, that's okay. That will work. But here keep in mind two things. In irrational numbers, we'll be having root 2, root 3, root 5. If I ask you about the root 4, is it rational or irrational?
Rational.
Rational. Why?
Because root 4 is equal to 2.
Correct. Okay. So root 2, root 3, root 5, these are irrational numbers. Similarly, if I say cubic root of 2, cubic root of 3, cubic root of 4, cubic root of 5, cubic root of 6, cubic root of 7, and cubic root of 9, and so on. We have not included cubic root of 8. If I ask you again, cubic root of 8 is rational or irrational?
Rational.
Why?
Because cube root of 8 is equal to 2.
Is equal to 2. That's right. It is very clear. that means square root, cubic root. Similarly we can go further, fourth root, fifth root, all those roots where we are not able to get exactly integers or say rational number, that kind of thing, p by q form, that will be included as irrational. Is this clear to us?
Yes, sir.
Okay, one more criteria there is. That criteria is based on the decimal systems. As we are starting, we must be having very much clarity about these things. All non-terminating plus non-repeating decimals are called irrational numbers. Do you understand terminating and non-terminating decimals?
Yes, sir.
Okay, let's take few examples. If I write 1.25, is this a terminating or non-terminating?
Terminating.
Terminating, that means it is just stopping after 2 decimal places, right? So
Yes.
it is terminating decimal. Take one more example, 1.2222 dot dot dot. Terminating or non-terminating?
Non-terminating.
Repeating or non-repeating?
Repeating.
It is non-terminating plus repeating. If I take one more example, 1.252525 dot dot dot, it is
Non-terminating but repeating.
okay. This is also non-terminating plus repeating. Okay. Take one more example, 1.252252225 2225 dot dot dot. It is
Non-terminating and non-repeating.
okay. So here non-terminating and non-repeating is included in irrational number, and the terminating decimal or say non-terminating and repeating decimals are included in rational numbers. Okay, terminating decimal and non-terminating plus repeating. That means if I ask you about this is an irrational number, right?
Yes.
Okay, further rational number is divided into few parts. The last thing that we have to cover in numbers, like we can have natural numbers. What are natural numbers? All counting numbers like 1, 2, as you mentioned, 4 dot dot dot. Similarly we have whole numbers. What are whole numbers?
All counting numbers from 0 to infinity.
Correct. 0, 1, 2 dot dot dot. What are integers? Integers are represented by z. Integers are
A collection of positive numbers, negative numbers and 0.
it would be better if we say positive counting numbers with its negative values, or say negative values, and then we can say including 0, right? Or say all natural numbers with its negative values including 0. If we just say all positive numbers, then it will be error. 1.2 is also a positive number, right?
Yes, sir. Can you repeat it again? I couldn't understand.
Sure. All counting numbers like 1, 2, 3 dot 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 with its negative values -1, -2, -3 dot 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 including 0, they are called integers, right?
Yes, sir.
Okay. Similarly we have some more kind of numbers like prime number. What are prime numbers?
Numbers whose prime factorization include 1 and the number itself.
Correct. Only two factors are there. Composite numbers?
Numbers whose prime factorization include other numbers apart from the number itself and
more than two factors we have, that are called composite numbers. These things will be continuously used in all the sets, right? The next topic that we have to discuss is representation of set, and there will be discussing about roster and set builder form, and there will be using these things. Note these properly in your notebook. Mention all these things. Okay?
Okay.
Anywhere doubt?
No, sir.
Oh.
good, sir.
Everything?
Yes, sir.
Okay, very good. That means if I ask natural number is a set or not?
It is a
Natural,
set.
it is a set. Whole number is a set. Integers is a set. Now the question arises, what are not included in the set? Not included like best players in the world. If I give you an example like this, best players in the world. Can you make a well defined set out of this? The answer is no. Best is a vague term, right? You will say that this player is the best, I will say some other player. That means it is not universally constant. But if I am discussing about natural number will be same for you, and for me also it will be same, and for any person who is residing anywhere in the country, right?
Yes, sir.
But if I ask the best players, every person will be having their own best. Is this clear to us?
Yes, sir.
That means whenever we see any vague terms like the best, or say collection of intelligent people, collection of happy people, collection of beautiful people, that kind of things. So whenever we see any kind of vagueness in the set, or rather it is not good to call them set, whenever we see any kind of vagueness in a statement, we will say it is not a set. Is this clear? Why? Because we cannot define it properly. It is not same for everyone. Doubt?
No, sir.
Okay. Let's do few questions. Which book you follow?
NCRT.
NCRT. Any other book?
Actually, they give extra workbooks of JEE and CBSE from our school, but the common one is, the primary one is NCRT.
NCRT. Okay. Okay then. Have you noted this part? We'll do some questions.
Yes.
Question is, the collection of most dangerous animals in the world. Is this a set?
No, sir.
Because how to define that who is dangerous and who is not dangerous? Is there any universal criteria? The answer is
No,
no. Right? It is not a set. And what will be the reason? We do not have any specific criteria to define who is the most dangerous and who is not. That means it is not well defined. And what are included in set? Those things which are well defined. Is this clear?
Yes, sir.
Okay. The collection of all odd natural numbers less than 10. Is this a set?
Yes, sir.
Why?
Because this includes well-defined entities.
Yes,
Like
they are very
one-
well defined. It will be 1, 3, 5, 7, 9.
9.
It will be same for you and for me also, right?
Yes, sir.
Now you can figure out that what will be included in set and what won't be included in set. Note this an example.
Noted, sir.
Okay. The collection of all rivers in, or say, of India. This will be
This is a set.
This is a set. We know that how many rivers there are, which river flows from where to where. These are very well defined, right?
Yes, sir.
That's why it is a set. Note this also.
Noted, sir.
Okay. Let's go further. The next topic that we have to be clear. There are many questions based on this in the NCERT. Your homework will be to do those, right? You can use the same concept to answer those questions. The next thing is representation of set. Representation of set. There are two ways, as I mentioned in starting also. There are two ways to represent a set. What are those? The one is roster form. It is also called as tabular form. You can say it as tabular also. And another is set builder form. What are roster forms? In roster forms, what happens? We write the individual elements. We write the individual elements. I'll take an example, it will be more clear. And here what we do, we define a rule. Let's take an example. If I have to write a set, one thing before that, whenever we are representing a set, will be always be writing using the curly bracket or say the middle bracket. Okay. So if we have a, this is curly bracket. Whenever we'll be writing any set, A is equal to, there will be curly bracket or say the middle bracket, and inside this will be writing whatever, either will be defining a rule or will be writing the elements. So here if I take an example of a set, I can write like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is a set representing natural numbers from 1 to 10, right?
Yes, sir.
In roster form, what we are doing? We are writing all the individual elements. But if I have to write the same set in the set builder form, what will I do? I will define a rule. I'll write like x is such that, this is the symbol of such that. This is the symbol of such that. And there is one more symbol that will be used. This is belongs to. Belongs to. X is such that x belongs to, these numbers are natural number, x belongs to n, and x is between 1 to 10. Is this clear to us?
Yes, sir. So in the set builder form, it is represented indirectly.
Yes, it is
That,
represented by
rule.
a certain rule, right, that we have defined here. But in
So the
roster form,
criteria is present in the set builder form.
yes, this is the set builder form. And this is the roster form. In roster form, what happens? We write all the individual elements. Is this clear?
Yes, sir.
Okay. Let's take one more example. If I am writing, suppose 1 square, 2 square, 3 square, 4 square, dot dot dot, this is up to 99 square. This is the representation in roster form, because we have written the elements, we have not defined any rule, right? If I have to write the same set, is this part clear to you?
Yes, sir.
Okay. If I have to write the same thing in set builder form, how will we write?
X such that x belongs to n square.
No, it won't be like that. It will just change the meaning. Here, whenever we are just modifying the set, what we'll do, we introduce one more thing. X is such that x is equal to n square. Okay, here n belongs to natural number. That means this is the set representing all the square only, right?
Yes, sir.
So x is such that x is equal to n square. We have introduced a new variable which is n, small n, and we are showing that n belongs to n, which obviously is, this is 1 square, 2 square, 3 square, 1 2 3 4 are natural numbers, and then it is going from where to where? From 1 to 99. Is this clear to us?
Yes, sir. So in these cases, we are supposed to like introduce a new variable and then.
Yes, yes. Earlier it was very easy. We were in condition to write directly the x belongs to natural number, right? But here we are not in condition to write it directly. That's why we are introducing a new variable. That is, let it be n. I could have taken it k also, right? I can take it as m also. There is no restriction to it. I can use any of the variable.
Okay.
Note this part. We'll practice some questions because this is important for us. So in roster form we write all the individual elements, we write the elements, and in set builder form we just define a rule. Noted?
No, so one second.
Okay.
Noted, sir.
Let's do some questions. If you have a as 1, 1 by 4, 1 by 9, 1 by 16, 1 by 25, 1 by 36, 1 by 49. Write a in set builder form. Initially it was given in roster form. Is this
Yes,
clear?
sir.
Okay. So here what we can observe,
All the numbers, the denominators are in square now.
correct. So we can write it like, here we have 2 square, here we have 3 square, 4 square, 5 square, 6 square, 7 square, and here nothing is there. That means here it is 1 square, right?
Yes, sir.
That means every time in denominator we can identify that there is square of the natural number. That means if I have to write, I can write it like x is such that x is equal to, in the format of 1 by something square. That means 1 by n square, right? Or is this clear to us?
Yes, sir.
Okay. X is such that x is equal to 1 by n square, and here n is belonging to capital N, which is natural number, and n is from where to where?
From less than or equal to 1, I mean greater than or equal to 1, less than or equal to 7.
Correct. Very good. Now you must be getting some idea that how to write the set builder form if we have roster form given.
Yes, sir.
Okay, try the next question. A as 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Write it in set builder form.
X will such that
X is such
X
that
belongs to
not X belongs to. Firstly, you will have to take X is equal to.
X is equal to 2 small n,
Very good.
comma, small n belongs to capital N,
Correct.
and then
N is between
n is between 1 to 10.
correct. You have got the concept. Clear?
Clear, sir.
Okay. Now let's do the reverse. You have noted also?
Yes, sir, I have noted.
Okay. Let's do the reverse. There will be many questions in the NCRT and some other materials if you have.
Yes, sir.
Okay.
The materials given in the school has them.
Okay. If we have somewhere set builder form given, like x is such that x is a natural number and x is between 30 to less than 36. Here it is given in set builder or roster?
Set builder.
Set builder. So roster form would be
A is equal to bracket 30, 31, 32, 33, 34, 35, 36.
recheck, there is error.
No, sir, until 35.
Yes. So 32, 33, 34 and 35. Why not 36?
Because it is less than 36.
Exactly, not equal. Equality is not there, that's why. Okay. Let's do some other question. If we have x is such that x is an integer and x is between -4 and 6. Try this.
The roster form is A is equal to bracket -3, -2, -1, 0, 1, 2, 3, 4 and 5.
-3, -2, -1, 0, 1, 2, 3, 4, 5, right?
Yes, sir.
Correct. Noted also?
Yes, sir.
Let's do some complicated questions. If we have x is such that x is an integer where x square is less than or equal to 9. What we can do here?
Sir, integer in the sense, can we take negative numbers?
Yes, we just defined integers include the negative counting numbers, positive counting numbers and 0. Right?
Yes, sir.
Okay.
Is it -2, -1?
Why not -3? Equality is there.
Oh, sorry, sir. I did not notice it.
Okay.
Then -3, -2, -1, also 0, 1, 2, and 3.
Correct. It will be -3, -2, -1, 0, 1, 2, 3. There is one more topic I think I didn't make you write in the rough structure. We have to discuss linear inequalities and modulus also. So when we'll be discussing the linear inequalities, we'll be discussing in detail that how to solve these kind of questions, right? For here you can just put the values and get the idea that what will be included, what not be included. But when we'll be discussing, we'll discuss in detail, and we'll be discussing the sign scheme part also. Okay.
Okay, sir.
Okay. If you have somewhere a as x is such that x belongs to R and x square minus 5x plus 6 is equal to 0. For this,
It is a quadratic equation.
yes, it is a quadratic equation. We have to write in roster form. No idea?
I'm trying, sir.
Okay, try.
I think the answer would be -3, -2, then 2, 3.
Okay, tell me the solution of x square minus 5x plus 6 is equal to 0.
-2, -3.
Very good. And you have got 99 marks. How can you get -2 and -3? You'll get 2 and 3. You have factorized it as x square minus 3x minus 2x plus 6 is equal to 0. You must have taken x as common. It will be x minus 3 minus 2 common. X minus 3 is equal to 0. X minus 3 again common. X minus 2 is equal to 0. Either x minus 3 is 0 or x minus 2 is 0. That means x is equal to 3 or x is equal to 2. Is this correct?
Yes, sir.
Okay, very good. So our answer would be just 2 and 3. There is no chance of getting negative. Is this clear to us?
Okay, sir. Then they have given real numbers.
So what? 2 and 3 are real numbers. Whatever solution we are getting, that should be real number. Suppose after solving, we get some kind of imaginary number. That means we won't include that solution in this. Right? What happens?
Okay.
In quadratic, you must have gone through the concept that if d is greater than 0, what happens? D is equal to 0, what happens? And if d is less than 0, what happens? Right? What happens in case of d greater than 0?
D greater than 0 means real and
Unequal.
distinct.
Yes, exactly. Real and distinct. If d is equal to 0,
Real and equal.
and if d is less than 0,
Imaginary roots.
imaginary roots. That means if after solving, suppose you are not able to factorize it, what you will do, you will use the quadratic formula, right? Suppose you are
Yes,
not
sir.
able to solve, I just change the equation. Okay, it will be more clear to you if I just change x is equal to, x is such that x belongs to R, and here I write the equation as x square minus 5x plus 7 is equal to 0. Can you solve this? The answer is no, you cannot. because when you find the d, you will get minus 5 square b square minus 4 into 1 into 7, which is 25, minus 28, which is minus 3, less than 0, correct?
Yes, sir.
That means it doesn't matter how much time we are giving, we won't be able to factorize it. D is less than 0. D is less than 0 means after using the quadratic we will definitely get a solution, but that solution won't be real, that will be imaginary. Is this clear?
Yes, sir.
That means minus b plus minus under root d by 2a. This is the quadratic formula.
Yes, sir.
So 5 minus of minus 5 means 5 plus minus under root minus 3 by 2, correct? So here we are getting imaginary solution. This is not actually real. So for this the roster form be what? Just empty set. There is no element in it. We are
What
getting
is this mean, sir?
this is called the empty set. Empty set, or say the null set. Null set, you can say it as null or empty set. Empty set. This means there is no element in it. You are getting the two solutions, but both the solutions are imaginary. But you need what? You need real numbers. But in the last question, what was the case? When we are solving, we are getting 2 and 3 and both are real numbers. That's why in the solution we have written a as 2 and 3. Is this clear?
Yes, sir. And the null set which we are representing, if there is
Five.
no solution,
This is 5. There are
Uh,
two. Okay.
we can't we represent it under bracket, like?
Yes, you can represent it as one more way. Just do not write anything inside the bracket. This is also called null set. Either you can write it as phi or you can write it as just like this. Okay?
Yes, sir.
Or have doubt? If have doubt, ask me.
No, sir.
Okay, very good. So you are now clear what is the significance of this R? X belongs to real number. If after solving you are getting real number, that means you will be including in the solution. If you are getting non-real number, that means imaginary number, you won't include in the solution. Here also you are getting the two solutions, 5 plus root minus root 3 by 2, 5 minus root minus 3 by 2, but those are imaginary numbers, right? We are getting imaginary solutions, but we need what? Real solutions. That's why A will be 5.
Okay, sir.
Okay. Okay, let's do 2 more questions. Can I remove all this?
Yes, sir.
Okay. Let's do one more complicated questions. Now you can do the simple questions easily. If we have A as x is such that x is equal to 1 by 2n minus 1, and here n belongs to natural number, and one more information we have, that n is between 1 to 5. Try solving this.
I got A is equal to bracket 1, 1 by 3, 1 by 5, 1 by 7 and 1 by 9.
What you did?
I got A is equal to bracket 1,
What
1
what
by
you did firstly? You must have put n is equal to 1 for the first element, right?
Yes.
That means 1 by 2 minus 1, which is 1, or something else.
1 only.
1 only. and then you will put at the place of n 2, that means 4 minus 3, 4 minus 1 3, that means 1 by 3. You have got the same?
Yes, sir.
Okay, then
I got 1 by 5.
1 by 5, 1 by 7 and
1 by 9.
1 by 9, and that is the answer. Very good. Okay, have you ever gone through the modulus mod x? Are you aware of this symbol? Any time, maybe in class 10 someone might have discussed with you mod x.
Yeah.
Okay, what do you understand by this mod x?
If that modulus symbol is applied to any equation or any term, if it is a negative, like modulus of -2, it is equal to 2.
Exactly, that's enough. That means if we have modulus of 2, it will be 2. If we have mod of -2, it will be 2 only. That means it makes the negative number also as positive. Positive will be positive, but negative also as positive. We have to discuss a lot about the modulus in the functions and in the linear inequalities. This is very important. We'll be discussing. Let's do a question related to this. If you have a as, there is a question, x is such that x belongs to z and mod x is less than or equal to 2. Think.
I got
You got
yeah,
answer as
-2, -1. What about mod 0, sir?
Mod 0 is 0.
0, 1 and 2.
Correct. You can apply the same concept that you apply with x square kind of, right? We did a question related to x square. X square also, x square less than 9 we did a question, right? X square
Yeah.
is less than or equal to 9. A similar kind of concept we just apply here. Okay. Let's do 2 more questions that is left, and then you'll be able to solve almost all the questions related to these. If I give a set like 14, 21, 28, 35, 42, dot 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 98. You have to write the set builder form. How will you write?
X belongs to
X is
X.
such
X
that
is equal to 7n,
correct,
small n,
correct.
and then n is
N belongs to
we have to like
natural number only.
natural number, but
N is between
this between 2 and then 14.
correct. Very good. You have got the concept. Okay. And the last question is A as x is such that x is a letter in the word mathematics. Try this.
bracket M A T
M A T
H
H.
E
Hmm.
I C S.
Why not M again?
Because M is already mentioned.
Okay, very good. So M A T H E, then I C
CS.
S. This is the answer. That means there is no need of repeating letters in the set. Okay, there is no need of repetition. And one more thing, remember, I can write the solution as this also: A M T H E I C S. What I mean by this, that means there is no importance of order also while representing set. You can, if you want, you can write M at the first place. If you want, you can write M at the last place. Is this clear to us?
Any order is fine.
Any order is fine. There is no importance of order while representing. If I have A and B as the element, I can write the same set as B and A. They will be same. Okay? Order have no importance in set. Clear to us?
Okay, sir.
Okay, that's all for
I
today.
have one.
Okay, ask.
In the word mathematics, the M is repeated twice,
Hmm.
and in the set builder, the roster form, if we mention M twice, is that considered to be wrong or invalid?
Yes, it will be considered wrong. You don't have to
Okay.
repeat the numbers. If you are writing in between somewhere, after that, if you are able to correct, you are writing just M once, then the final will be correct. But your final answer can never be like including one element twice or thrice. Okay?
So one element has to be, it must be mentioned only once.
Only once.
Okay.
Okay? We have
Yes.
discussed from the starting. Firstly, we discussed, we just gone through the rough idea that what we actually have to discuss in class 11. Then we started the set. We gone through the numbers and all concepts. Then we discussed that what are set, what are not set, and then representation of set, and we did a lot of questions. And you have noted everything, right?
Yes.
Your homework is to solve questions from the NCERT at least and do the further question and collect the doubts, then we can discuss in the next class. Are you clear with
Okay.
all the concepts?
Yes, sir, I'm clear.
Okay. Okay then. How was the class?
It
Hello.
was good, sir. I was able to understand.
Okay, that's okay. Okay then.